Okay, so here's what we're going to talk about now for a little bit, as almost like a break between chapter 4 and chapter 5. It's a short little thing on matrices. I have this quote in here. I'd have you pause and read. I do love this quote about mathematics. I'm actually going to kind of talk about going the opposite way. So it's the idea of mathematics really just being kind of the study of things that are already there. Like we kind of assume that the universe follows natural laws, and therefore human beings are going to do their best to uncover what those laws are and then work with them. But what we do with a matrix, okay, is we create something on our own. Matrices are a totally human construct. So it's saying, here's what a matrix is. We're going to make it up, and the rules for how a matrix works are human constructions. So it's a way to organize numbers. In the same way, like I say, it's a human construct where you'll see it get used a lot. And why I do like that we go over this is coding, which again, like that's a human construct, is coding, the internet, those types of things. So it makes sense that this field of mathematics, matrices being a human construct, pops up in other things that are a human construct, not really something that exists naturally. So it's a rectangular array of numbers enclosed by brackets. The rows and columns will determine the dimensions of the matrix. So this one to our right here, this is a 4 by 4. The numbers inside are called the elements, so each individual piece is an element. And we always write it as rows times columns. So when I say that it's 4 by 4, this one obviously it wouldn't matter. But this is rows and this is columns. You always write R by C. So it's always, how many are you going this way? That's how many rows we have by how many columns we have. So in this case, it's 4 by 4. So obviously, wouldn't matter if I wrote that one the other way. Columns by rows would also be 4 by 4. But let's get into the important stuff. All right, special kinds of matrices. If you just see row matrix, that means it's literally just one row. So a lot of times we'll say, something they come up here and show me what that is. And somebody goes, I don't know, like that. I go, yep, just one row. A column matrix would be something like this, 2, 3, 4, just one column. So I'd write this one in particular, rows by columns, is a 1 by 3. This is a 3 by 1. So this has 1 for the R, so it's a row matrix. This has 1 for the C, so it's a column matrix. And then a square matrix is anytime it's like the example we did, or that was on sort of the first slide, the 4 by 4. This one's 3 by 3. Let's talk about operations. Adding and subtracting. I'm going to tell you right now, we will only perform adding and subtracting a matrix if we have the same dimensions. It's a human construct, so these rules are all rules. If it's, so let me do a quick one, 3, 5, 8, x, all right, plus 4, y, 7, 9. If I added a column in here, I've completely undone. I can't add them together. That's just not how it works. And then you'd kind of suspect what happens here to happen. You're just going to add things that are in the same place. So 3 plus 4, 7. 5 plus y is 5 plus y. 8 plus 7 is 15. 9 plus x is 9 plus x. And that's the new 2 by 2. So that's how adding and subtracting are going to work. They're very straightforward. So there's some examples in here that I'd recommend you give a shot. Okay. Scalar multiplication will be the last thing we talk about today. What does it mean to scale something? This is where I kind of want you to fall back on things you've learned in geometry. Scaling something up or down means you're applying the factor to everybody. So scalar multiplication, just like addition, is very straightforward. It's, hey, apply this 5 to every single piece of this, which is a row matrix, right? It's just one row. So that now the row matrix is going to look like this. So there's your brief introduction to matrices. We're going to get into more complicated stuff like multiplication, inverse, all that type of stuff later. Try some examples. There's a practice worksheet. And I hope this video is helpful.